Hi there, everybody. My name is Rob Fatland. I'm a research computing director at the University of Washington, and I'm kind of stepping in for Amanda Tan to present on using the public cloud. And I'm going to explain what that means. This should take hopefully about 20 minutes, and if you are a longtime cloud user and a cloud pro, then this will be old hat, and I wouldn't take it amiss if you looked into other things at the moment. This presentation is essentially for someone who is heavily involved in the water side of the research here and has questions about what's involved in using the public cloud to do research computing. So hopefully this is going to act as a kind of a 20-minute feasibility / introduction to some of the basic ideas, terms, jargon, and that kind of thing. So my objective is to try and demystify cloud use, if there is any mystery, in relationship in particular to Jupyter Notebooks, Jupyter Notebook servers. There is a repo that goes through the stuff that I'm going to talk about, and I'm going to use the opportunity that I had to create this talk to augment that repo with this talk. So it's a little bit of a cart and a horse or a chicken and an egg thing, but the point is that we have a repository that's Christina's DHSVM-OPT GitHub repo, and the question is, what would it take to get that rolling on the cloud, kind of independent of Binder, independent of a GitHub, a Jupyter Hub controlled environment, that kind of thing. So really this is sort of about going off and launching your own infrastructure, which you would be in charge of. It's fairly straightforward. It's not trivial. The leading questions that I got from Christina are what cloud platform could you use? And by public cloud, I typically mean a publicly available cloud that's operated by a cloud vendor, such as Amazon Web Services, which is the cloud we'll be using today, or the Google Cloud Platform, or Azure, or Microsoft Azure, or there's a number of other cloud platforms out there also. Those are the three big ones. I work at UW in support of research computing, and that means that I spend a lot of time talking about the cloud. And we also have an NSF-sponsored program that generalizes the kind of stuff that I do to the academia writ large. And that project is called CloudBank. So you'll see that it's referred to in this slide as CloudBank-project as a GitHub repo. So CloudBank is a consortium of University of Washington, University of California, San Diego, and UC Berkeley. And we are building out support for NSF-funded projects to do their research computing on the cloud. And as such, we have a cloudbank.org website, and that has a lot of information available. So I'm going to move on here from this. By the way, my background is in geoscience. Actually, I was once I guess I'm still a glaciologist. So I've had a long history of working with technology and kind of enjoying that, but trying to figure out how to use it for research. So I'm really on the research mindset side of things. I'm not really an IT person. So I run into a lot of I don't get it problems and have to sort of work through that, and I try and leave documentation to help other people do that also. So the executive summary of this now is that there is a path to your own supercharged Jupyter environment on the cloud. It's not trivial, but it's doable. Help is available. This is the link to the repo. Using the cloud is super flexible because you get to decide how much computing horsepower you bring to the problem. I'm not going to talk today about clusters, and there is a project called Pangeo that does do automation of cluster computing when you really need to get into some gigantic horsepower. But I am going to talk about the fact that you get to choose the size of the computer that you use, and that can change from one day to another, or 1 hour to another if you like. Furthermore, the cloud is always available, it's always there, and the amount of money that you spend for it is proportional to the horsepower, the cloud computing power that you're using. That's the first part of the summary. The second part of the summary is, how do I pay for it? And the answer is, you want to try out the cloud on some free credits. You can go and sign up for a cloud account, and they'll give you $100 in credits, and try and do some stuff and see if this works for you, and if it's a good fit, if you feel like you're doing well and understanding what's going on, Then you would proceed to go ahead and set up a real bank account with necessary dollars to pay for your cloud use, and set up a real account, and just go from there. There are research credits available from the cloud vendors, and I can tell you more about that. You can contact me, Rob5, numeral 5 at uw.edu, and the Cloud Bank website is there also. So let's get down to it. My goal here, as I say, is to demystify the use of the cloud. The first question that we often get is, how do I interact with the cloud? And this on the right here shows the first answer, which is that you do it through your browser. The cloud has a console. So you get your credentials, you log into this console, and then you use the various menus to navigate around and allocate resources. And once you've allocated them, because you're authenticated into an account that has dollars associated with it, then you get charged for your use. It's like a utility model, like a power supply or like water. The next level of interacting with the cloud is that there is a command line that you can install that allows you to interact with the cloud remotely, so you can talk to it sort of from your own computer. And then thirdly, there is a coding interface, which means that you can use a library, like a Python library, to talk to your favorite cloud and tell it what to do. And this is really nice as sort of an evolved way of interacting with the cloud, because you can write code and then forget about it. So if your code is working correctly, if it's interacting with data sets, with loading data into memory and that kind of stuff, then that's fantastic. You can forget about it. That's the idea of writing code, is you don't have to do stuff over and over again. Same thing with the cloud. If you can sort of submerge it and forget about the fact that you're using the cloud, that's the best of all possible worlds, because the cloud unto itself is kind of interesting, but after a few minutes, you kind of want to get back to your, you want to get back to DHSVM. So that's what we're trying to get to, is how quickly can we solve all the infrastructure issues and get you back to your research, which is what matters. Mystifying question number 2, where is the cloud? Is it like in a cloud? And no, the answer is the cloud is actually in Oregon. It's also in Ohio and in Paris and in Milan, but it's not in Prague. So you'll notice over here on the right, I have a listing of locations in the cloud. And when I first jumped on the cloud today to set this stuff up, I was looking for what we're going to be working with, which is a cloud virtual machine, an image of it, and I couldn't find it. And then I finally realized, oh, it's because I'm looking around in North Virginia, but it's actually in Oregon. So if you are looking for something in the cloud and you can't find it, that's a little hint, is like you're probably looking in the wrong region. Each one of these is a facility being a large complex of buildings that are full of millions and millions of computers. And they have these centers distributed around the country, around the world, obviously, and then you would connect to the one that's closest to you to minimize your communication time. Okay, and I also made the point here on this page that everything we're doing on AWS, you could also do on the other clouds. Okay, so everything is about image on the cloud, but the term image I need to define specific to cloud computing. So an image on the cloud is simply put a tar file of your operating system, and that can include a working environment. So for example, Jupyter Notebook servers, data sets, the code that you've written, your Jupyter Notebooks, all that stuff can be kind of bundled up into a tar file and stored as an image. So when you hear that term image, that's what it's referring to. So what I'd like to do is walk through in a sort of pictorial way the process of starting up a computer on the cloud. And we're going to do that before we obviously get to the subject of getting DHSVM transferred from GitHub onto that machine. So you'll notice that I'm captured a browser here, and that there is a sequence of steps starting here. Choose AMI. So AMI stands for Amazon Machine Image. So there's that word image. And I want to find the image because that's going to be the operating system that I'm going to use in what follows. And then there's 6 more steps that follow, and we're not going to belabor all these steps. So step 1, choose an image, and the very first image that's listed here is called Jupyter 1. That's an image that's already been built. And I'm going to select that, and that's going to be my Ubuntu operating system that's got some pre-installed stuff on it. And once I do that, I come to step 2, which is really important, which is how powerful of a machine do I want to use? Okay, and so I can get a really small machine that runs cheap, like pennies per hour, or I can get a super powerful machine that costs dollars per hour. And that's where my virtual machine is going to start up on. Okay, then I do some configuration. I can add additional disk drives. I can tag my virtual machine that I'm about to spin up on the cloud. I can create some security around it, and then I can review it, make sure that I have a key pair file so I can log in. And what I'm going to do is I'm going to start this on the cloud, and I'm going to get an IP address, and I'm going to connect to that from my own local machine. So I decided to get a machine on Amazon called M5AD.12 extra large, which is very mysterious, but I happen to know it's a sort of general purpose computer and that it costs some amount of money. How much does it cost? I had no idea. So I went into Google and I typed cost M5AD.12 extra large, and Google immediately told me that this machine is going to cost me $2.47 per hour, which for a couple of hours is not that much. But for a year, which is a lot of time, that's going to be really expensive. That's going to mount up after a while, right? It's 50 bucks a day, 70 bucks a day. So, but it's really easy to find out how much a particular machine costs. In other words, you just type that cost in the name of the machine, and it shows up in your browser really quickly. Furthermore, I went and looked up what exactly do I get if I buy or if I purchase time on an M5AD.12 extra large, and the answer is I get a 24-core computer with 192 gigabytes of RAM, and on board is 1.8 terabytes of SSD disk space. So the nice thing is my $2.47 per hour gets me a pretty beefy machine, and this is sort of what I would call in the middle range of powerful computers on the cloud. So you haven't even touched the surface here as far as the really powerful stuff. But again, it's a little expensive. Okay, so question number 4, we just saw that that machine costs $2.70, right, per hour for that machine. Does it always cost $2.70? And the answer is no. It doesn't cost that much per hour, because the first thing is, when you fire up a machine on the cloud, you have a start-stop control, and when you stop it, you're no longer paying for it. It's just kind of sitting there in off state and waiting for you to come back and turn it back on again. So then you're just paying to sort of store the tar file of the entire machine, which is cheap. Secondly, you can use what's called preemptible virtual machines on the cloud. On Amazon, they're called spot market instances. And if you choose that option, then there's a chance that you will get kicked off of your machine, a very small chance, but that cuts the cost by about 80%. And then finally, there is the fact that because we're talking in terms of these images, which are the operating system tar file, you can stop a machine and take that image, save it, and then restart it on a different machine that costs a lot less. So if you're just going to do let's say editing code, you don't need to be spending $2.70 per hour for a code editor. So you can just start it up on something that costs a few pennies per hour, do your editing, and then shut it down and restart it on a powerful machine when you actually want to do the computing. So this is what I mean by the flexibility of using the public cloud. You can move your environment around onto different computers, which is difficult to do when you're working with computers that you own. So I earlier highlighted those sort of 7 steps in the wizard. This is from the very last step, which is I've done all the configuration of my virtual machine. I've selected the image. It's got Jupyter pre-installed on it. I'm ready to go. The last step I need to do is make sure that I get a key pair, which is a little bit of SSH cryptographic protocol security, and that file is going to be used from my local machine to authenticate myself into the virtual machine on the cloud that I'm about to start up. Rather than using a password, I'm going to use a key pair. Okay, so I launched the instance, and as I do, that takes me to a table of the instances that I'm running, including the new one that I just started up, and I noticed that it has an IP address, and so that's what I'm going to use for SSH. Okay. Let's see, I'm seeing some questions and I'm wondering if I'm missing anything. Somebody should just hop on a microphone and yell at me if I'm missing questions that as we go.
Rob, I'll say that if you can manage to see questions in Slack, all power to you. We don't expect that of you. We are monitoring Slack questions, and you can stop midway or in 10 minutes, and then we're also answering the simpler questions. But the idea is that we would moderate and ask the questions to you. Again,
Okay.
some people can multitask and check Slack, and all power to you if you feel you want to do that.
Okay, great. I'll just carry on and let you interrupt me when when it seems appropriate. So this is obviously a Ubuntu bash shell window, which is terribly hard to parse. So please don't try and parse this. I'm going to highlight the important stuff using red ovals. So this is on my computer. That's why the prompt says my computer. And you remember I mentioned that there's a key pair file, that's the authentication file. There's an important little step here, and this indicates the kind of technical acumen you need to develop to use the cloud. You have to run a Linux command, chmod 400, that changes the permission of this key pair file, and that makes it sort of a step closer to being secure. So great, you got to sort of do this like it's a magic spell. And then there's a next command here, which is, again, this is from my computer, and it's SSH, and it uses that key pair file. And then it says Ubuntu at 34.212, etc. So that's the IP address of the cloud computer that I've just started up. And it's sitting there humming away, doing absolutely nothing, waiting for me to show up. So this is how I connect. And everything below this red oval is now a printout of my connection to that computer. So down here at the bottom, you see it says base, Ubuntu, add, etc. So that's the prompt on the cloud computer. So I'm literally on the cloud here. And when I said ls, it said, well, there's an Anaconda 3 directory and a chlorophyll directory and a data directory. So there's no DHS VM yet, but there is some other stuff going on this computer, and that demonstrates that that image has content. Okay, so I'm going to interrupt myself here to say that if all this is going by in a blur, don't worry about it. It is outlined in the instructional GitHub repo that we set up, and that will allow you to go step by step through each of these pieces, and that's the game plan. So the last thing that happens on the cloud computer up here is this top line. I've indicated that it's on the cloud by showing a little cloud icon. And you'll notice that the command is Jupyter lab -- no browser -- port equals 8889. And that's running in the background. That's the ampersand. So in other words, I'm telling the cloud computer, start up your Jupyter lab environment, your notebook server, but don't try and put anything to a browser. Instead, sit there and listen to port 8889 for a connection. And the computer says, great, that's fantastic. And here, by the way, is a long token string. It's actually much longer than this. I just cut it off. Here's a token string, and I have to copy that down into a text editor or something. And then I quit this computer, and I go back to my computer. So then the next line, the middle line here, is my computer, and I do another SSH command. But this time, I don't try and connect. Instead, I just connect a localhost port, which is 7005, to the distant cloud machine port, which is 8889. So once I do that, that connection exists, and that's called an SSH tunnel. And what it allows me to do is take traffic on my local machine to port 7005, and it reroutes that to the cloud machine. And this is going to allow me to set up and run a Jupyter lab on my own machine. So in my browser, I type, here's the fourth line here. I don't know if you guys can see my cursor, but I'm on the fourth line of this slide. It says localhost :7005. So I type that into my browser and hit return, and lo and behold, a Jupyter notebook pops up. So what I'm doing is I'm actually going through that tunnel, and I'm talking to the cloud machine, and it's sending me back the Jupyter environment. And I type in that token that I got earlier to authenticate. So what I'd like to do now is go to, let's see, maybe I can go escape, yeah, and show you what that looks like. So hopefully you are seeing now a different tab on my browser. This is a Jupyter lab. It's on my cloud, on the cloud machine, but I'm seeing it from my own laptop because of that SSH tunnel that I set up. And you'll notice that I have a tab here that happens to be a notebook called Chlorophyll. And next to that is another tab, which is a terminal.
Hey, Rob, could you increase the font a bit?
Yeah.
Thanks. That's great. Thanks.
Okay. So, oops, looks like I overshot. Okay, let's hope that's good. So I'm going to run a command here on the command line. And again, I'm on a terminal in a Jupyter environment on a cloud computer that's costing me $2.47 per hour. And this Jupyter environment was pre-installed, so that was sort of sitting like on a shelf on the cloud. And now I'm going to rerun command 149, which is git clone https github.com Christina B dhsvm.opt. So what's that done? Well, that's gone out to the cloud, to GitHub, and it has copied this repo, this repository. And now when I say ls, there it is, and I can cd to dhsvm and say ls, and here's all the stuff. And now at this point, what I didn't have time to do in preparation for this, and I'm definitely running long anyway, is to do all the configuration steps using the requirements.txt and pip install and so forth for running this environment. But that's not important. The important part is I wanted to demonstrate the sort of the feasibility and the steps necessary to get to the point where you're actually running a Jupyter lab in your browser from your computer that's using a cloud machine. And that cloud machine, as I say, with those 24 cores or something like that is a fairly powerful machine. So that's, I think that's everything that I wanted to show you except for my little conclusion slides. So let's go back to my conclusions here. Right, so unvarnished, this is an unvarnished summary. I didn't want to soft sell it or make it seem easier than it is. There's a number of steps that you have to go through. And so that's why I always try and advocate using the cloud is something that you get into if you're curious about it and it seems like it's going to solve some problems for you, and then you try it out a step at a time, and if everything's working great, then off you go. But I didn't want to like make it sound like easier than it is because there's a number of these steps. And it would be much more fun to do it with other people is kind of a, hey, let's all go do this together, because then you can sort of ask questions and coordinate. But you'll notice that in setting this up, I'm completely independent of somebody else's Jupyter Hub. So I didn't have to go to some other Jupyter Hub and go and log in and get a container, and that container is going to be a fractional piece of somebody else's machine. It's probably not going to be as powerful of an environment as the one I just happened to choose to set up today. So it's a way of giving yourself a less constraint on the amount of computing horsepower. Let's see. Yeah, this process applies to any cloud, and then I use an SSH tunnel to make this happen. You can use remote desktop, and there's other ways of accomplishing this kind of stuff.